My name is Johann Fischbacher.
My name is Anna Kasabor.
And my name is David Böhm. We are working at the University for Continuing Education KREMS in Austria. Our group is part of the CoCoMag project. By combining theory and experiments, this project accelerates in the development of new magnetic materials for technologies like electric vehicles and magnetic refrigeration. Many current devices rely on elements such as rare earth metals and cobalt. However, these materials are limited and expensive. CoCoMag explores complex alloys to design new materials without these elements.
We focus on theoretical modeling of magnetocaloric materials used for next-generation cooling technologies. Magnetocaloric material can heat up or cool down when a magnetic field is applied. In many materials, the magnetocaloric effect is linked to a phase transition, where the crystal structure and magnetic state change with temperature. We use numerical and analytical models to study how these transitions occur and how they depend on the material and its microstructure. The simulation shows how the high temperature phase, shown in black, changes into 3 low temperature variants, shown in green, blue and red, as the temperature decreases. With this approach, we can see how the microstructure affects the cooling performance. This helps us to find optimal microstructures and explain what we observe in experiments.
Another contribution of the University for Continuing Education KREMS within the CoCoMag project is to better understand permanent magnets. To do so, we apply the micromagnetic theory. In simple terms, we create a model of the magnet at a scale that is small enough for simulation on modern high-performance computers, but large enough to observe the processes relevant for the magnet's performance. The input for the simulations are the so-called intrinsic material properties provided by our experimental partners, plus the representation of the microstructure. Optimizing the microstructure is essential to obtain a good permanent magnet. Therefore, we also include information about the size, shape and orientation of the micrometer-sized grains inside the magnet.
A major advantage of CoCoMag is the close link between simulation and experiment. Our experimental partners use our results to produce real materials and test them in practice. Our goal is to make cooling technologies and permanent magnets more energy efficient and reduce their impact on the environment.